So in much of what we will do in this chapter, you'll need to be able to draw curves. The curves don't have to be perfect, but just to give you a feel for kind of what you're looking at. In this case, we have a normal distribution, which is a bell-shaped curve. The mean is 65, so that means the point of symmetry is 65, so that is mu. Keep in mind, this is mu equals 65. In terms of the empirical rule, what the empirical rule does is it gives us a rule for one standard deviation above the mean. So suppose that is one standard deviation. In this case, the standard deviation, or this distance, is 5, which means this value is 70. And if we go one standard deviation below the mean, this value is 60. If we go another standard deviation in both directions, then this value is 75, this value is 55. And if we go one more standard deviation in each direction, then this value is 80, and this value is 50. So notice what we have here, within one standard deviation based on the empirical rule, and the empirical rule works exactly for a normal distribution, we have 80% of our data. If you got two standard deviations, which is from here to here, then you get 95% of your data. And if you go out three standard deviations, which is from here to here, you get 99.7% of the data. There are very few observations that are beyond that. So keep in mind that these are your x values. Those are possible outcomes for this normal distribution. And then you get intervals based on the empirical rule for 1, 2, and 3 standard deviations. Another thing I want to mention here is I want to mention the z-values based on these x values. As we just talked about in the last example, the mean always has a z-value of 0. The standard deviation sigma here, as we said, sigma equals 5. So this distance from 65 to 70 is one standard deviation. If you calculate the z-value for 70, that z-value is 1 because it is one standard deviation above the mean. The z-value for 75 is 2, and you can use your formula to see these. The z-value for 80 is 3. And if you go in the other direction, you get a z-value of -1, -2, and -3. So notice what we've basically done here. By changing my x values into z values, I've changed this normal distribution with a mean of 65. Notice in this case my mean is 65. I've changed that mean for the z values into a mean of 0. I've also changed this standard deviation of 5. Now that distance goes from 0 to 1, so for this z distribution, this distance or this standard deviation is 1 whenever you talk about the z distribution. So whenever you transform x values into z values, if they come from a normal distribution, those z values are now normally distributed with a mean of 0 and a standard deviation of 1. This is a very important characteristic of z values. So it's important you understand the empirical rule, but it's also important you understand how those z values relate. Also notice if you get a z-value bigger than 3, that's very, very unusual. If you calculate a z-value and you get 17, that's a very unusual value. You will get a value between -3 and +3 99.7% of the time. So you always want to check yourself if you get unusual values for z. That's another good use of this empirical rule.